Okay, we're going to continue our discussion of forces, and we're going to introduce Newton's second law. And it's a mathematical relationship between acceleration, the net force on an object, and the mass. And this makes sense because as the net force on something increases, the acceleration is going to increase. But as the mass increases, as something has more inertia, it's harder to change its speed, so acceleration decreases. You're normally going to see it written this way. And that's what we're going to use to, for 90% of this unit, we're going to be using F net equals ma to find, say, the acceleration of the system with forces on it. So the first application is going to be weight. Weight is defined as the force of gravity. And we can do this. We say weight equals the force of gravity. Now, if I look at this equation, F equals ma, then the force of gravity is going to be m times the acceleration of gravity. Which on Earth is about 10 meters per second squared. So here's an example. An object has a mass of 4 kilograms on the Earth, and I want to find its weight on the Earth. So, we can do Fg equals mg, find the weight. Fg equals mass was 4 kilograms, mg is 10 meters per second squared. Say the force of gravity on it is 40 per kilogram meters per second squared. Which would be fine to write it that way, but we also know that the unit has to be in newtons. So we can write it as 40 newtons. It's kilograms meters per second squared is equivalent to newtons. Now, for D, mass on the moon. It's a bit of a trick question because mass doesn't change. Mass is not weight. Weight is defined as the force of gravity. So it's going to depend on gravity, where mass is inertia, and it does not change. And then for part C, I want to find the weight or the force of gravity on the moon. We use the same equation, but now the acceleration is going to be 1.6. So the weight, or the force of gravity on the moon, is going to be 4 kilograms. That's 1.6 meters per second squared. And I'm going to get 6.4 newtons for the weight. So the mass is the same on the moon, but since gravity is weaker on the moon, the force of gravity is going to be less. Next thing is normal force. So we're going to try to draw this. We have a table. We have 20 kilogram mass sitting there. We want to identify all of the forces on the mass. So there's a force of gravity down. And over here we can do Fg equals mg, 20 times 10. That's going to give me 200 newtons. So say the force of gravity is 200 newtons. Now that can't be the only force on the mass, because if it was, it would fall down. So what's happening is the table pushes back up on the mass with what's called the normal force. And the normal force in this case is going to be 200 newtons. I know that these have to balance since it's at rest. Because anytime the force is balanced, it's going to be constant speed, and in this case, it's at rest. Now, the definition of the normal force is the force between surfaces. And it is always perpendicular to the surface. Okay, the word normal in this case doesn't mean not strange. It means perpendicular. Top of the next page. All right. Free body diagrams. You draw all of the forces on an object. Okay, and nothing else. So a 30 Newton block is being pulled across the table by a force of 15 newtons, force of friction is 3, acceleration of the block is what we're looking for. So if I was to sketch it, I might do something like this. I have a 30 Newton block. Pulled this way with a force of 15 newtons. I have the table down here. Okay, and then I got another force back the other way, force of friction. But when I do the free body diagram, I don't draw the table, I only draw the block that I'm interested in. So I have the block here is 30 newtons, and I want to draw the forces acting on it. Well, I know gravity is acting on it down this way. Okay, what keeps it from falling down through the table? The table pushes back up with the normal force that way. I have a force of 15 newtons pulling it forward, and then it says I have a force of friction of 3 newtons back that way. All right, now let's figure some stuff out here. I kind of threw a curveball in there, maybe tricked you a little bit. I gave you 30 newtons block. Newtons is a force unit, so I'm actually giving you the force of gravity this time. So the force of gravity is 30. The normal force would also be 30. And they're going to cancel each other out. Now, I am going to need to know the mass of this thing, so I can go back and calculate the mass using this. So 30 is 10. That tells me M, the mass is 3 kilograms. Now, F net equals MA. Okay, F net is the unbalanced force. Okay, so I have 30 up and 30 down, they're balanced. I have 15 to the right and 3 to the left. That gives me a net force of 12 equals 3 times A, and A is going to be 4 meters per second squared for the answer. Okay. Example 2. 10 kilogram block pulled across the table with a constant speed of 3 by a force of 20. So, I'm going to draw the block, 10 kilograms, and I'm going to label all the forces on it. Okay, well I know there's a force of gravity down. That's equal to M times G. 10 is the mass, gravity is 10, so this is 100 newtons. There's a normal force up from the table. And since it's not moving up or down, they have to cancel, so that's going to be 100. Because I have a force of 20 newtons this way. Okay? Now, it says I'm going at a constant speed of 3 meters per second. I don't want to draw that on my free body diagram, okay, because it's not a force. I only draw forces. But I do have a force of friction back this way. I want to know what that is. There's a couple ways to do it. I'm going to do it this way. I'm going to say F net equals MA. So the 100 up and the 100 down cancel. I have 20 forward and some force of friction backward. Let's imagine the force of friction was 15. What would the net be? 20 minus 15 is 5. You always subtract them. So for my F net, I can do 20 minus FF equals, the mass is 10. And then I have to figure out what the acceleration is. Now, the trick to this one is it's a constant speed of 3. I don't want to use that 3 in there. That's not the acceleration. That's the speed. A constant speed tells me the acceleration is 0. So I can put 0 in there for the acceleration. And if I solve it, I get F equals 20 newtons. Now, another way I could have done that was just look back here at the free body diagram. And when I see constant speed, Newton's first law says, if it's constant speed, the forces all cancel. So I could have looked at this without doing this step here and just said, I know the force friction has to be 20 because the forward force is 20 and it has to balance and we're going at constant speed. Next example, acceleration of the system below. So we got to look at each piece of it, okay, and draw a free body diagram. And whenever you have a string in here, we're going to say that it produces a tension T. That's the force it produces. So if I look at the 4 kilogram guy, what forces are acting on it? There's the force of gravity down. It's going to be 40 newtons, because I would do m times g, 4 times 10 is 40. And the normal force up, and that's going to be 40 newtons as well, because this thing is not going to be moving up or down. It's just going to be sliding to the right. I have tension over this way, okay? And then I don't have any force back the other way. We're going to assume this thing is frictionless. So that's my entire free body diagram for that guy. Now, my next step after I get my free body diagram is to write out my F-net equation, F-net equals ma. Now in this case, the 240s cancel, and what's left to be my net force is the tension T. So my F-net equation becomes T equals 4A. And I can't solve it, I got 2 unknowns, so now I have to start looking at the other block. If I look at the other block, draw its free body diagram. The forces on it are, I have force of gravity of 20 newtons down. Okay? And then I'm not sitting on a surface, so there's no normal force. The only thing pulling upward on it is the tension T. And I do my F-net equation for that one. So they're in opposite directions, so I'm going to subtract. And here's a trick. I'm not going to say it's 20 minus T or T minus 20. If I think about it, that block is going to go down. So the 20 is going to win. So the 20 is going to be bigger than the T, so I'm going to do 20 minus T. Put the mass of that block in as 2, and then times A. Now, there's a couple ways to solve this at this point. What I do is I just add the 2 equations. So I get T plus 20 minus T. All right, that's the right side, the left side of the 2 equations. Equals 2A plus 4A. I like to do it that way because if I do it right, the tensions will cancel, which happens. And then I get 20 equals 6A. I can combine those. And then A is going to be 20 divided by 6, which is 3.3 repeating meters per second squared. That number makes sense, okay, because if this block over here was just falling, it would be 9.8, okay? It's going to be less than that because it's being held back by the other block. And this is going to be the last little video that we do. So this looks kind of confusing, all right? But I'm going to do the same type of thing. I'm going to draw my free body diagrams. This one, M1. And think about the force acting on it. There's a force of gravity down. Now, I'm just going to leave it as M1G. I'm not going to put any numbers in this one because for this problem, it's very generic. Okay? And maybe we're not on Earth, so I'm not going to use 10. I'm going to use G for that. So I have M1G pulling down, and I have this string pulling up on it. So that's T. Now my other block, I have 2. I have the force of gravity down on it is M2G. And I have the same string pulling up on it, so that's going to be T up that way. Neither of them is sitting on a surface, so there's no normal force. Now, I have to do my F-net equation for each one. Now I look at this, and I know they're in opposite directions, so I'm going to subtract. So I'm going to do M1G minus T, or T minus M1G. And that's why I put this in here, okay? Assume M2 is bigger than M1. That means M2 is a heavier mass. It's going to fall. So I know the direction for this one's going to be this way. The direction for that one's going to be up. So now I know that the T for this one, the T is going to be bigger than M1G. So it's going to be T minus M1G equals M1A. There. On the other side, I know this block is going to go down. So F-net equals MA. It's going to be M2G minus T equals M2A. So those are my 2 F-net equations. Now, like I said, I generally add those together. All right, so it's going to be T minus M1G is the left side of the first equation. And I'm going to add it to the left side of the second equation. And then I add the right sides. if I do it right, my t's cancel, and I do, I have a plus t here, minus 3 here, so they cancel. And I'm left with minus m1g plus m2g. So what I'm going to do on this side is I'm going to factor out the a. And then to get the a by itself, I would just divide by that. So then a is going to equal minus m1g plus m2g over m1 plus m2. That is my final answer.